Yes.
Okay. You ready? Go.
Good afternoon, everyone, and deans. It is an honor to be on the stage this afternoon. We are from Group 7. My name is Maman Marif Hassin from ITB.
I'm Diksha from India, but I'm studying in Institute of Science Tokyo in Japan.
Hello, I'm Zhou Yuan from HKUST.
Hello everyone, my name is Sena from ITB.
Hello everyone, my name is Chen Zhenxi from Tsinghua University.
And today we're going to give a short presentation on how we can use design thinking, which is an engineering practice, to come up with solutions for renewable energy in Bandung. So first of all, I'm going to explain a bit about design thinking and why it's such an interesting process. So, next please. Okay. Design thinking is a common practice that we found to be used in a lot of our countries and a lot of our disciplines, and in fact even in disciplines outside of engineering. So it turns out one of us have taken an entrepreneurship class, and we also got taught about design thinking in that class. And basically, design thinking is a process where we create solutions by first finding out about the problem before making the solution. So we don't start from the solution, but instead we find out more about the problems, we find out the details, the potential requirements before finally making a solution and choosing the best one. There are 5 stages to design thinking. So we have empathizing, which is finding more about the problem. Ideating, which is basically making some ideas on how to solve it. And then, before ideating, defining, which is defining the problem even further. So after we get the data, we make clear what the problem is, and then we do ideating, which is coming up with solutions. After that, we do prototyping and testing, but because of the constraints of this project, we're going to stop at ideating. Next, we're going to immediately start to empathize about the problem, which is sustainable energy around the globe.
Yeah, so next slide. About the global situation, so because my team members are from India, Hong Kong and China, so I have covered those 3 countries. So specifically about India, presently there are 30% renewable energy share, which is less because India's population is the highest in the world. So only government has planned to reach 50% by 2030, and there is another goal set by Indian government is biofuel revolution, where government has targeted 20% mixing of ethanol by 2050 because we are cutting down on petrol because of the fossil fuel things. And then comes the Hong Kong, because this country is very small, maybe the RE share is less than 10%, 1%, and that's why the government has targeted for 10% by 2035 and then other ambitious projects. About the China, the RE share is presently 26.4%, and there are the 2 terms coined. First one is carbon peaking, which means China has said that after 2030 there will not be any carbon producing devices. It should start decreasing, and once they achieve carbon peaking, they have planned for carbon neutrality, where the emission and the removal will be equal. Next slide. So in line of the previous slide, China is presenting to manufacture the winter wines on the offshore positions and making it the largest market for the ops by 2030. And because I'm studying in Institute of Science Tokyo, I saw in the chemical laboratory there is fuel cell development. So I have discovered what Japan is doing for hydrogen fuel cell. So they said that they will increase the manufacturing of hydrogen 6-fold by 2040, and it will make its position at 10% in the global market share. About India, we know that solar energy is being talked everywhere. So, but in India, problem is about the acquisition of land. So instead of rooftop solar or any other things, India has planned to go for the floating solar park, and the ambition is to manufacture 600 megawatt, which is in Madhya Pradesh, which is in India. But the problem is, it has started, but it has not yet commissioned. But once it gets over, it will be the highest in the world.
Okay, so for the next part, we're going to talk a little bit about Bandung. Next. Okay, so for starter, Bandung had over 1 million total electricity customer. This number basically emphasizes the high energy consumption and the growing number due to a couple of factors, one of which is the population number. Okay, next. Okay, so this is some key facts. Bandung has over 2.5 million total population with a growing number of 22,000 people per year. So, talking about geography and weather a little bit, Bandung, or especially Indonesia, located in the ring of fire. So basically, there's a lot of geothermal energy potential due to its volcanic activity. So for weather, basically Indonesia has rainy and dry season. This photo basically the expected weather for the next week is basically gonna rain all week. So for the legal and policies in Indonesia, there's basically some policies called RUEN and RUET. That is basically a general energy master plan that is constructed by the West Java province and the national committee. So for the issues that we come up with this presentation is the waste problem. This photo is taken yesterday at the Bandung ITB waste management facility, and Bandung is the largest contributor of waste in the TPA Sarimukti or waste management facility in West Java. Next. Okay, so we're going to talk about the energy source and energy potential in West Java province, which is the province which Bandung is located. Only 0.6 gigawatt out of 170.4 gigawatt of West Java has collected in renewable energy. So this chart basically, out of 100%, there's only 23.4 renewable energy used in the West Java province. This basically consists of solar power plant development, plastic waste, and sorghum cultivation. The picture and number in my left basically the potential based on the West Java master plan. There's a lot of potential in geothermal, biomass, and hydropower.
Okay, next. Right, so now that we have empathized regarding the problem and potential solutions from all over the world, we can define the problem into a clearer sentence or explanation. So basically, the problem is that Bandung continues to increase in both population and economy, so the energy requirement continues to grow higher, but at the same time, we have to make sure that the energy being produced is sustainable. Because if we keep using fossil fuels like coal and oil, it's going to run out someday, and if it runs out, the entire population is going to suffer. But at the same time, we have to make sure that the energy is also clean, because if the energy is not clean, it's going to damage Bandung's ecosystem even further. So yeah, what we want to solve is that Bandung requires more energy, but it has to be sustainable and clean. And from the previous slides, we also identified several problems that we have to solve. So in Bandung, we said that the weather is rainy and there is a bunch of tectonic activity. So from there, we have to make sure that any solution is also suitable with Bandung's weather. And then other examples such as geography, like the tectonics, and then viable, efficient, and effective, because the economy is not very large, so we can't make solutions that require a lot of theoretical work, a lot of money, and then also sociology and legals, like laws and policies that are mentioned previously, and lastly, of course, sustainable. So,
1 minute left. 1 minute left.
Basically, any solution must to be proven to be able to produce energy efficiently and effectively, but also suitable with Bandung. And it also has to involve many multiple fields, so not just one. Because, for example, of course, power generation requires electrical and power engineering, but maybe also thermophysics because it burns biomass, or IT because the control system uses computer. Also involves legal because we need to comply with local laws and regulations. So next we can give you some examples of power sources in the ideating phase, that some of which are already being used in Bandung and some are theoreticals that we think might not be that suitable. Can I skip? Okay. 5 minutes.
Hydropower is a very important renewable energy source. As you can see in the first page on the right, this is a hydropower station not far from Bandung, which is also the largest world conservancy project in Indonesia. In the second picture, we can learn the principle of hydropower and theory. Hydropower has many advantages. It's clean and renewable, and compared to other renewable energy sources, the occlusion of hydropower is more predictable and more stable. Hydropower stations often have a lifespan of around 50 to 100 years. It can also bring great economic benefits and job opportunities. But the construction of such a project may requires a great number of costs and may bring a series of environmental impact.
Okay, talking about the geothermal, we might know what is geothermal. We are listening about the geothermal energy right from the beginning. So just to give a recap, geothermal energy is just the heat tapped from the earth's crust, and then it is made turbine run, and then with the help of turbine, it is getting converted into electricity. So there was a report in 2020, Indonesia becomes the second largest country in the geothermal power production, and it was very surprised. I was very surprised to see this data. But the problem was the utilization of geothermal power in Indonesia is only 7.6%. So there is huge potential. Indonesia can do a lot more thing in this area.
Thank you, Diksha. So biomass is another renewable energy sources. It's very attractive because the best part is it converts the waste from wood, from crops, from trash into energy. So there are three ways to convert for the conversion: direct combustion to produce heat and then electricity, or we can use chemical conversion or biological conversion to produce the fuels and fertilizers. So we are engineers, right? We love numbers, we love data. So yesterday we had a great conversation with the local waste treatment center, and the people here told us that they have a huge potential for this biomass to apply in Bandung. So they now face some low recycle amount, around 15 to 20 kilograms per day per station, compared to in total 3 to 4 tons of garbage. And also the efficiency is quite low because they use the maggots to naturally decompose the food waste. But so they have only 4 kilograms to 1 kilogram fertilizers. The conversion rate is quite low. So obviously we have very good reasons to introduce this biomass because this has reduced waste, it has low cost, it's versatile, and it's carbon neutral. And of course we need to solve the problems about the supply chain for waste. We need to increase efficiency, and also we need to solve some technological challenges. And as you can see here from the right, actually our university here, ITB, has already established some cooperations with a Japanese company called IHI to develop this conversion from the biomass to the fuels. So, of course, there are some other options for the renewable energy, wind, solar, and nuclear, but they all face very huge challenges in Bandung. And the primary reason is cost. So the cost for all of this, for the infrastructure, for the land, is massive. And also the instability of the wind, of the solar. So because of the weather, the wind here is not stable. So they are all facing some limitations here. So based on our research, and we can completely summarize here, short-term biomass energy is a great choice to increase renewable energy, and in the long term, we can transfer from the power source into geothermal and the hydroelectric. And thank you for all your attentions, and we're happy to answer questions.
Okay, thank you, Group 7. So we have time for questions from the deans. Is there any question?
Thank you for your presentation. For the biomass, okay, it seems like it's the top choice from all the alternative solutions. So, however, the process of biomass still requires electricity and chemical compounds or chemical or bulk chemicals. Okay, so I'm just wondering, have you considered the whole process of the biomass production using green energy? If the process still requires burning carbon fuels to produce electricity, and you turn that biomass into the other form of fuels or electricity, so what is the gain in that process? Okay, so have you incorporated renewable energies into the process of biomasses? Thank you.
For sure, if we just directly burning those waste, it can cause several problems, pollutions, CO2 emission, and of course, we want to develop something, introduce some microorganisms to decompose those food waste, and also this requires some technology related to biological engineering, maybe microbiology, something like that. And we believe that the ultimate way for this biomass is to use biological conversion. And so, as I mentioned before, they just use the box of lice, the maggots, to decompose as a current stage. So we still have a long way to go.
Maybe an additional reason why we put biomass as a top choice is because in Indonesia and in Bandung, there's still a bad habit of people just burning the trash. So they dump it outside and then they burn it, which is bad, right? It's better if we can collect the trash first, even if that process takes a bit more energy. In the end, the energy isn't wasted because we can get energy from the waste instead of it just being burned outside.
Okay, thank you, Group 7. We have to move on to the next group. So let's give applause to Group 7 again. Okay, and the next one is group number 3. Yes, 3.
All the best.
Please wait.
Okay, good afternoon, Mr., Miss, and friends. I thank you for your time. Now we are from Group 3. We are going to share our group discussion result about smart minibuses in Bandung. But before, I want to introduce ourselves. My name is Rico from ITB.
My name is Arifki from ITB.
My name is Vika from Japan.
My name is Robbie from Science Tokyo.
My name is I'm from Vietnam.
My name is Charlotte from Taiwan. My name is Fatia from ITB.
Okay, first, we are talking about sustainable transportation, and sustainability is very related to energy consumption. You can see from the bar chart in the left side of the slide. It was obtained from Indonesia Minister of Energy and Mineral Resources, and you can see from the orange bar that transportation sector consumes more than a third of the energy in Indonesia. Therefore, it was important to optimize the energy consumption in transportation sector to obtain a sustainability transportation. But there's a serious problem, which is the number of public transportation is very low compared to the motorcycle and car or private vehicle. The scale in the bar chart is a logarithmic scale. So, next. And there's another major problem. Even though the public transportation is already low, there's a declining trend of the number of passengers. This is the Transmetro Bandung number of passengers. Transmetro Bandung is one of the public transportation in Bandung, and in 2023, it is lower compared even to a pre-COVID condition. And as we student experienced before, Bandung has serious traffic jam problem. When we go to waste management facility yesterday and the micro hydropower facility yesterday, we got traffic congestion, and the traffic jam can have many
negative impact like wasting money, wasting fuel, and psychological impact, where the psychological impact, the stress, can lead to increase in traffic accident. In West Java, the province where Bandung resides, it happens 9,014 traffic accidents in 2023.
Okay, thank you, Rico. So now, I would like to highlight our focus because we talk about sustainability. You know that in the previous slide that transportation is require many energy and also, yeah, this one is one of problem. Next. So we are focusing on traffic jam. So why does it comes as emphasized by Rico before? There are two main causes. The first one is the public transportation is not reliable. So if you talk about public transportation in Bandung, especially, it's really not reliable. You cannot fix your schedule. So if you want to go to some place, you could not know when will you come and what is your travel time. And also, it's also not reliable because there is no dedicated bus stop here. So it's why people in Bandung just move to the private vehicle. That means the ownership is high. Okay, so the causes make the traffic jams. The traffic jams have implications like this. The bad quality of life. So I think everyone, if having a traffic jam in their life, they will be so hard, like these pictures. And then high emission, of course, because in every vehicle, it will be produce a very serious emissions, and it will result in global warming. And the last one is also the high probability of the traffic accident. Okay, so what is our approach to solve this kind of issue? So we try to begin of the end of line. So we know there's a traffic jam, and we know that the solution is like this, no traffic jam. So there's a gap here. So why can we fill this gap? We try from the causes, and we want to make an ideal condition, our desired condition. People want to use public transportation because it is reliable, and they will lower their ownership in the private vehicle. So the implication is like this. We have a better quality of life, and then lower emission. That means our environment will be safe. So this is our end of mind. So what's our approach? We focus on the two things. The first one, two things. And the first one is a smart minibus system. So Bandung, and I think in every place in Indonesia have a unit of the public transportation, which is angkot or minibus. So we would like to improve the system of the minibus by using our proposed smart minibus system. And then for the environment condition, we will also to have a conversion from the fossil fuel into electric. But I think we have a time limitation, so we make two terms. The short term is to make the system convenient, and the longer term is to focus on the energy side. So what is the details of this 2 point of solution will be elaborated with my friends.
Okay, so let's move on to the short-term plan. So as our short-term plan, we named Smart Minibus System. So as Japan and Taiwan has developed transportation system, but it is a little bit difficult to use that system directly to Bandung. So we proposed minibus for the Bandung roads because the road in Bandung is very narrow and because of the high population density, so we think minibus is the best choice for Bandung. So in order to accomplish smart minibus system, we offered 3 small plans: bus stop, online system, and promotions. So Charlotte, can you explain it more detail?
Okay, so next we will talk about the short-term plan detail. First, we will set up some bus stops, and we will also organize the route and time schedule. We discovered that there are various kinds of minibus routes in Bandung now, but there are too many kinds, so we may want to reorganize the route to make a much simpler one. And next, we will set up a time schedule for a minibus. We will decide how many minibus will depart and when will they depart. The second, we will also set up an online system with our minibus because everyone uses Google Maps to search for transportation information now. So we want to upload our precise minibus location to the Google Map, and when people use the Google Map to search for the information, they can know when the bus will arrive, and they can decide when they will go to the bus stop and wait for the bus. And we also want to use the smart payment method, such as using the phone or IC card to pay for the fee, to save for the time of paying cash. And last, to promote the minibus, we will offer some student and elderly discount. Also, we want the government to give some subsidies for the passengers. This is because we want to encourage the passengers to transfer from private vehicles to public transportation with a cheaper price.
Okay, we also have long-term plan. In June 2023, balance power reserve in the Java Bali system reached 44% with a total oversupply of 6 gigawatt. Then, why not we just reduce the electricity generation capacity? Unfortunately, it's not that simple because there is a take or pay scheme that requires PLN to buy electricity from private power producers, whether or not it used by consumers. This plan aims to utilize the excess energy of converting conventional minibus into electric minibus. The conversion will use minibus with a full battery of 45 kilowatt hour and capable of traveling up to 300 kilometers per charge. By using electric minibus, Indonesia excess power can be absorbed, preventing it from going to waste. This initiative is expected to contribute to more efficient energy utilization and support environmental sustainability in Indonesia.
So, if we want to convert all the public transportation into electrical, won't we need more power plant for that? Correct. And by having, we need to more power plant, doesn't that mean more emission? Correct again. But the difference is, if we are concentrating the emission on the power plant, we change it from the distributed one, from the vehicles, to the concentrated one, to the power plant. So what's the benefit? The benefit is there's a technology called carbon capture system, which is, just like its name, it captures the carbon from the concentrated source. And this is actually aligned with our regulation of 2021, which greatly support carbon emission reduction. And then there is our ministry's running plan, which, if the project succeeds, it will create thousands of jobs while also reducing emissions by 33 million tons. So it's not just killing two birds with one stone, but it's killing many much more. Next. So why don't we all right now just sell our car and just buy Tesla Cybertrucks? Because it's too expensive. But there's a recent study from Antara News that it's been 15 years and it's over 90% that the battery prices is already declining. And a renowned company named Goldman Sachs from America, this is an investment company, it predicts that it will drop by 40% by 2030. So it will drop even more. And then our government, through PLN, which is an organization that we visited yesterday, it is creating over 600 charging stations right now, and it targets to reach to 25,000 by 2030. So it will make the availability for electric vehicles even more. Next. And this is our running projects, which I've mentioned earlier by our ministry. There are currently 15, and we are hoping to make it much more. Next. And so, this is the future improvement. The first is, as I've said earlier, more charging station. And then the second is charging road. This may seem like an impossible, but it's already been installed on Detroit, I think, on America. And one more solution which I can propose is, if you want to sell a product, you need the customer to taste the product first. If you want to sell the food, you need the customers to know that the food you are selling is delicious. So if we want to make people use our reliable public transportation, we need to make the people use the public transportation first. How do we do that? There is a policy called even and odds in Jakarta, in which in even days, people can only use even license plate, and on odd days, people can use the vice versa. So we need to enforce that policy on Bandung when we already have a reliable transportation system. That will make the people use the transportation systems, and how good it is, it will be spread by word naturally. Next.
Okay, so far we talked about the future transit smart minibuses in Bandung. So as a short term, we suggested smart minibus system. We focus on the convenience of the minibus. We want people to use public transportation rather than private vehicles. And in the long-term plan, we focus on the pure conversion into electric. So we want to change gasoline minibus into electric minibus for more sustainable energy way. So if we can accomplish these two plans successfully, it is obvious that we can change Bandung into a more sustainable and safe road situation. But isn't it too optimistic? Is it really feasible plan? Actually, we can do it because there is already an example in Vietnam. Vietnam has already using electric bus as a transportation way. So let's move on to the Vietnam.
Thank you for your introduction. Now I'm going to tell you about the energy bus in Vietnam. It's the effectiveness of energy bus in Vietnam and the sustainability of our solution for Bandung minibus energy. As you can see in the picture, this VinFast bus and is produced by VinFast. VinFast is the largest electric vehicle manufacturer in Vietnam. They produce motorcycle, electric car, and even bus. So back to the energy bus, they are just like conventional bus, but the difference that they use, they operate the engines on electric city. It's very friendly with environment. Second is according to the statistic Hanoi from the introduction of electric bus is releasing around 40,000 tons of carbon dioxide emissions, and which is equivalent to 1.68 million trees. Impressive figures, right? So it's also easy to implement because we have infrastructure for them. We don't need to build any special infrastructure for them. Just replace the gasoline bus to electric ones. So I believe that electric bus is a new change and a long-term solution for Bandung to move towards sustainability transportation. That's all about energy bus. Now we can see that energy minibus is not a dream. It's a near future for Bandung. Yes.
Okay, so that's near the end of our presentation. But I want to amplify that the solution is realistic enough because the technology is established. It is not a level of rocket science or rocket engineering. So I think Bandung, as long as has an initiative from the local government, supported by the province or the nationals, and also together with the academia, the researchers, to make this kind of happen. The short-term smart minibus system and the longer-term, the fuel conversion into the electricity. So I hope our proposal idea is good to solve the traffic jam in Bandung. Thank you very much for your kind attention.
Thank you. We have time for questions from the deans, please.
Thank you for the presentation. It's quite interesting, your ideas you put forward. Just a comment and then a question. Excuse me. So I think the idea that you put forward would be beneficial, but one of the things I was wondering about the timeline. You say short, what is short, long, what is long. And the other thing, I think looking in Bandung, you see a lot of scooter drivers, right? Driving the scooters. What happens to them? They're probably driving for their living or trying to support family members. How do you consider people who are employed by the current system.
So, okay. So, do you mean like Gojek or Grab? Oh yeah, okay. So, people like that. So, the main goal of our presentation is to replace the fuel, right? So, if we can make the long term successful, then we will change the motorcycle itself publicly into electric, like in Taiwan, right? Like in Taiwan, as far as I know, the people there use electric vehicles for like Uber or Uber food, yeah, etc. Things like that. So yeah, we want to start by implementing the public transportation into electric first, and then, like if I said, there is the future improvement slide in which I said that there will be more charging stations. If there are more charging stations, that means that the electric vehicles are also publicly available and it's publicly affordable. And if it's publicly affordable, then people that are using fuel can also change into electricity. And I think right now there are already some, well, it is not very good maybe, but there are a little organization that made electric scooters. Also, maybe it is not very fast, it is not as fast and as convenient as the fuel one. But as I've said, if we make the long-term growth successful, then it will be as convenient as the fuel one, and it will attract more people, and people can make it as a job too. Thank you.
Yeah, can I ask a short follow-up? So I was thinking in Japan recently, car ownership is gradually decreasing overall, and more car sharing is becoming more popular. And so as a result, there's fewer cars on the road. Did you guys consider car sharing as well as part of your solution?
Yeah, of course. I'm also the user of a car sharing in Japan. So it's like really convenient because I have family in Japan, so I need a car to transport my family, but I don't have this kind of money to buy the car. And because of the car sharing, it's just like they have a calculation. Calculate if you use this shared car compared to your own private car, it contributes to the reducing the CO2 emissions. So I think if the car share is also moved into the electric vehicle, it's really promising. I think it's the same. I think the principle is just make the private vehicle reduce, and our approach at first to give the option of the public transportation. But of course, like a Uber, like a car share, if they can change to the EV, I think it's more profitable.
Thank you for the presentation. It's a very well done, thought through project. My question is, did you think of how you could use AI and data to further optimize your solution?
I think AI can use to predict like the most crowded route in Bandung, and maybe AI can estimate how many cars will stuck in the traffic jam, or when is the popular time for traffic jam, and maybe we can adjust the policy of minibus to deal with that problem. This is my imagination of how AI can use in our smart minibus system.
You did a great job, yeah. Thank you.
Group 3, thumbs up. So let's applause Group 3 again. And now time for the last group, Group 8, please.
Good afternoon, everybody. It is my honor for me to be here. I am representing Team 8, and our topic is sustainable industry practices. And before we get started with the presentation, I will introduce you our lovely and very smart and very interesting members. Next slide. Can you guys come up and do your self-introduction?
Alright, hi everyone. My name is Alif. I am from ITB. So next, would Bulan come out?
Hello everyone, my name is Chitrahan Alia Bulan. I'm from Institute of Technology Bandung as well.
Hello all, my name is Maria Demetri and I'm from ITB too.
Hello everyone, I'm Xu Ziqi. I'm from Tsinghua University.
Greetings everyone, I'm Tan Hong Wen from Malaysia actually, and I'm currently studying in Institute of Science Tokyo.
And I'm Alvin. I'm Indonesian, but I'm studying in Korea in KAIST. Next slide. So before we get started, I'm going to give you a brief overview of what we will present. Sustainable industry in Indonesia, which means we will do a brief overview, just a very shallow overview of what Indonesia is doing in terms of sustainable industry practices, and then we'll move on to the actual local problem in Bandung, and then we'll move on to global solutions that we might apply to the problem that we have in Bandung. Next slide. So let's take a look at the industry in Bandung. The industrialization in Indonesia started since the 1980s after the oil drop, and it transforms the main industry from agriculture into industry. But when the industrial processes or the industry gets more and more developed, of course, we have to make sure that the industry does not destroy the environment. We do not want to deplete the environment and the resources for the sake of the industry. So, the Ministry of Industry issues a green industry standard to make sure that the environment stays protected. And also, there is a program to evaluate the company's performance depending on how environmentally friendly they are. So they're given ranks or ratings called proper. So from this rank, we can know how environmentally friendly a company is. Next. Focusing on Bandung, we have 18.73% of Bandung's regional gross domestic product coming from the processing industry. We have several industrial zones where factories and industries and companies, they all gather together in one region and they do their manufacturing, production, and so on and so forth. We will focus on Rancaikek Industrial Zone, which is here, consisting of 33 factories doing cosmetics, electronics, food and beverage, fishery, automotive, and most of all, textile and garment. So, but the problem is, next, in Rancaikek Industrial Zone, they're currently experiencing up to 60% decrease in groundwater levels. This indicates very intensive groundwater extraction, which means the factories, it was found that the factories were fetching groundwater more than the permitted amount, or more than they are allocated for. Then, because of that, demand is substantially larger than the supply, and of course, that means the groundwater levels is steadily decreasing, and even until now. Next. So, this is the issue that we focus on. Groundwater crisis, we can divide it into three aspects. Industrial water use, of course, because the industry is using more and more water and the water supply is depleted. We have also reduced absorption area because we are developing the industries need buildings. When you build on top of soil, you compact soil, the soil's absorption capability is reduced, and also you have less soil area for the water to be absorbed. And also, we have deforestation. We need to clear land to make more space for the buildings, for the industry to thrive. So, not yet. So this is the problem that we are facing right now. So, next. Let's look at the global solutions then. Of course, we will look at specific solutions, specific practices, but specific solutions are hard to implement because China, Japan, South Korea, they all have different culture, different technologies, different capitals, different political situation, different education background. They are all so different. So how we approach this thing is, we see the policies and the solutions in all these countries, we seek to summarize them by one word. China, we have optimization. China focuses on optimizing what can be optimized. Existing processes that can be optimized will be optimized. In Japan, the theme is centralization, meaning the role of government and large companies are very important to dictate the direction of the whole nation in terms of sustainable industry practices. In South Korea, we have symbiosis. Symbiosis means between industries, between companies, between factories, they all share and recycle resource among one another. I will go into that in more detail later. But first, let's go to China. Next. Optimization. Let's look at Tsinghua Brewery. They optimize heat recovery from water boiling and cooling, bottle washing machines, washing water. They take the leftover heat, they use it for some other purpose. They also reduce its carbon emission by using digital intelligent management systems like IoT or AI. They also manage their wastewater by sending them to a sewage treatment plant to be used for biomass energy source, therefore reducing environmental impact. Lastly, they push their recycling rate to 100%. They are able to recycle all of the distillers' grains, waste yeast, and broken glass, and etc. This is what the Tsinghua Brewery is doing. Next, we have another example for media green industry, or MEITI. Okay. So this is like an industrial park where software and hardware are integrated between sensors and systems so that they can allocate part energy smartly in between the participants, but not only where it is allocated, but also the levels of the energy based on the load and demand, and electricity price can be controlled in a smart way. Also, the whole park employs a carbon emission monitoring system so that each company can have a clear guide on how to monitor their emissions. So this is China's optimization approach. Next, we have Japan. Centralization. Again, this is the role of government and big companies like Toyota. Toyota Lean Manufacturing is a framework for the company to be able to manufacture in an environmentally sustainable way. This framework can be used by Toyota and also other companies as well. The government heavily invests on electric vehicle and fuel cell investments, therefore again, setting the trend for the whole country, and also employs carbon pricing on industries, penalizing and discouraging companies that has large carbon emissions. And something that only the government can do, overseas collaboration with, for example, Asia Zero Emission Community. So again, you can see from this that the government is directing where the country goes in terms of the sustainable industry practices, and the government supports these practices so that they can be implemented. Next. We have South Korea. South Korea, the theme is symbiosis. In Korea, there is a thing that is called Eco-Industrial Parks, or EIPs. In the Eco-Industrial Parks, we have resource sharing. Water, heat, and steam is shared between companies, between industries, between factories. It is made possible because in EIP, there is an extensive network of water, heat, and steam sharing system underground so that it allows companies to do so. They also do byproduct reutilization. This company sends their residue or waste to this company to be used for raw materials. This company doesn't have to worry about waste disposal. This company doesn't have to worry about raw materials. Win-win solution. We also have, this EIPs also can standardize policies and requirements across the whole country. You don't have to enforce your policies on specific factories or specific companies, but you can enforce that in specific parts, which makes your job a lot easier. Participating companies, we have Hyundai, SK Energy, POSCO, S-Oil, LG, large companies, which I'm sure everybody has heard of. Next we have Indonesia. So Indonesia has also been doing these things, and Indonesia is also heading towards this direction. We have Indonesia joining UNIDO's Global Eco-Industrial Parks Program, GEIPP, in 2020, Indonesia is also building an energy management system through the Benefits project. 1/3 of industrial parks, they plan to use solar photovoltaic cells and bioenergy, implementing that into their energy mix, and also following China's optimization scheme, again, adapting advanced manufacturing schemes, benchmarking against China. So, next. I remind you again the problem in Bandung. Let's go back to Bandung for a bit. Groundwater crisis caused by industrial water use, reduced absorption area, and deforestation. How can the global solutions, the themes, help these issues? We propose some solutions. Next. First solution, biopore infiltration hole. So it is a simple, cost-effective technology, but it increases the local permeability coefficient so that the soil can absorb more. As the soil gets compacted because of industrialization, we need to recover some of that pores, which, well, we can just make some more holes. Let's make some more holes, and it improves the ability for the soil to absorb water mechanically. But we can also improve that non-mechanically by adding bioactivators. Joining mechanical and non-mechanical ways, we can improve the water retention of the soil and soil absorption coefficient, therefore optimizing the existing process. The soil can already absorb water, but we want to optimize it. And so we maximize the infiltration following China's optimization mindset. Next, let's expand our scale a little bit. Let's think a little bit bigger. So we have soil aquifers. Soil aquifers, basically we force the water back into the ground by collecting them and letting them drain through the ground. Here we have natural filtration. And again, this is emphasizing the natural, the existing processes, and we just optimize it. We just use that existing process and we use it in a better way. So here, the source of the water, it can be pre-treated water, it can be storm water from the capture zone. So again, this is showing China's optimization theme. But now, since it's a bigger scale, we need the help of the government to be able to centralize and support this effort to be able to make this possible. Next, reclaim water. Now, water that has been used, wastewater, it can be treated to meet the standards for non-potable applications, such as toilet flushing, landscape irrigation, street cleaning, and such domestic applications. But I want to focus on industry applications. I want to use this non-potable water for sharing in between industries. Wastewater from one industry gets treated, and then if possible, we want to reuse them again for another industry. So, we want to create this industrial symbiosis, and since this water treatment plant is not cheap, we need the help of the government, but not only that, because we have some benefit from this wastewater for the companies. So companies that join in this wastewater program, join in this wastewater network, they should be able to invest in this wastewater facility because it will reduce their costs. Now they're incentivized. Now they have something to gain by investing in this wastewater system. So this naturally encourages the company and the industries to invest and to help reduce the cost that the government needs to supply to the systems. Again, emphasizing industry symbiosis and centralization. Next. So some cost analysis. Biopore infiltration hole, very cheap, very easy, very simple to implement. It utilizes very simple materials. It promotes agriculture, easy to implement. You can distribute them with some training. Everybody can use them. Everybody can implement them in the industry areas. But for aquifers and reclaimed water, you can see it's relatively a lot more expensive. This is where we really need the government to step in and centralize the whole thing. Of course, for biopores, we also need the government to be able to socialize and to give information properly, right? But for aquifers and reclaimed water, we need the government's help. Next. So for conclusion, we have wastewater management and reutilization, promoting symbiosis, resource sharing, and also we have low effort, high impact initiatives to optimize the soil's absorption capabilities, right? Implementing these two can make us solve the groundwater reduction problem. But to make these two work together, we shouldn't forget the role of centralization. The The government is important in supporting these wastewater management facilities and incentivizing companies and industries to invest also in this technology. Here, the government needs to make a network that can socialize and that can let people know that this is an easy and viable solution. Next. That is it for our group. Thank you so much for listening. It is an honor to present before you today. Thank you.
Okay, let's move on to the Q&A session. So please, if you have questions. Is there any question from the deans?
Thank you for your presentation. I think I have two questions. Okay, the first one is because I would imagine the soil will be highly sensitive once it has been, the water has been drawn. Okay, and then now you make it more porous and try to make it replenish the waters. However, without policy supporting policies, okay, you cannot guarantee that the industry will extract even more waters out of that ground, okay, when it is being replenished, and therefore making the ground even more sensitive because you have already been implementing like a artificial porous into the foundation. So I'm just wondering, have you think about why the industry in that part, okay, in that particular part, extracting water more than they should? Are there any like a government, like a checkpoints or any type of fine or the regulation that sort of limit their practices? Okay, I think that's probably one part you have to also think about as well, because the engineering side, the human side, okay, they need to work together. Okay, and the second question is, I would imagine that for Indonesia, it is surrounded by sea. Okay, is the desalination. Okay, so like a seawater treatment to get rid of the salt. Okay, desalination technique that is practiced in Indonesia now. Okay, whether that will be the most efficient way to have more fresh waters. Okay, for any type of use. Thank you.
Thank you so much for the question. Let me summarize the question to make sure I didn't miss anything. First question is basically making pores in the ground, replenish the groundwater, and then the industry is just going to take more water out of it, making the ground more porous. So is there not any policy or any rule checking why is the industry taking so much water? Is that correct? Right. And the second part is, what about salt water purification and replenishing the water from the saltwater source? Right. Thank you so much.
Okay, for the regulation of regulating the usage of groundwater by the government, they can monitor the usage of groundwater from each company or each factory periodically, maybe each quarter, each month, or each year. And that is one way, and if any company uses exceeding number of groundwater, the government could give them a penalty. However, a more greater long-term solution is to place a limit on the industrial zone. So maybe in one industrial zone, certain companies need less water and certain companies need more water, so they could be sharing the resources of the groundwater. So for the second question regarding the desalination.
Okay, regarding this second question, which is about desalination of seawater, Bandung area is kind of far from the sea waters. That means that if you really want to treat the water, means we need to construct a huge pipe to draw water from the sea back, and then that is a huge manufacturing cost there. And then the reason we suggested the reclaimed water is that every time we use water, we always it will become a wastewater. And reusing that water is which match our team with sustainability, because we recycle it. That's, I think it should be answered your question.
Okay, I guess that's all. So thanks a lot again for group A. So let's give applause to the group again. Okay, so thank you. I'll give it back to Guru.